Solving trig equations using trig identities. All right, back to solving on the interval 0 to 2 pi, so finding solutions on the interval 0 to 2 pi. In the last video, we did all solutions. This one is 0 to 2 pi. You're going to see some trig equations that look similar to things we've seen, but they're different because they can't be solved using any of the techniques we've worked on so far. So I look at tangent squared theta minus 3 secant theta equals -3. And this is troubling to me. I know what to do, scroll all the way back up. I know what to do when I have like something where there's a sine squared and then a regular sign. So the same function, right? And then it's a squared and a regular, because then I can do a substitution, make it a quadratic, factor the thing, right? That works really great. We've done that before. We've also had it where there was just a square term, no singular power terms, and we were able to solve those. But this is different because this right here involves secants and it involves tangents. And we don't have any techniques that will allow us to solve this. However, we do have tons of identities. So when I'm looking at this, my first thing my brain thinks is, can I use an identity? If you look at the identities we have, clearly we're not doing a double angle thing. There's no double angle in there. So clearly this is something that would use like a Pythagorean identity. Um, and all of these identities are dealing with the squared terms. So if I'm asking myself, like, which of these am I going to replace? Well, the only thing that's in these formulas are squared terms. So I'm thinking to myself, all right, tangent squared theta, what does that equal to? Well, right here, tangent squared theta, or tangent squared x, is equal to secant squared minus 1. Tangent squared theta is equal to secant squared theta minus 1. So I'm going to rewrite this equation as secant squared theta minus 1 instead of tangent, minus 3 secant theta, that was from the original equation, equals -3. I'm going to move this 3 over, so add 3 to both sides, and then rearrange it so it looks like a quadratic. So we have secant squared theta minus 3 secant theta. Add 3 to both sides, we get +2 equals 0. This is an undercover quadratic like we covered in a previous video. If you need more information on the solving process, go back to that video. Here, I'm going to let u be secant theta. U is equal to secant theta. So this becomes u squared minus 3u instead of secant plus 2 equal to 0. This gets factored. So we have u minus 2 times u minus 1 equal to 0. Replace those u's with secant thetas. So secant theta minus 2 times secant theta minus 1 equal to 0. And now this is something we've solved before. This is identically something we've solved before. I guess let's make you smaller. I'm running out of room here. Oh no, Apple Pencil. Everything's going wrong. All right, so take this guy here. We have secant theta minus 2 equal to 0. So secant of theta is equal to 2. The soulmate, and you are legally responsible for putting this little heart every time we talk about soulmates. Very important. Soulmate of secant is cosine. So cosine of theta is equal to the flipsy-flu, the reciprocal of 2, which is 1/2. Cosine represents x values, right? I come onto the unit circle. I say, where are the x values 1/2? Positive x values happen on the right-hand side of the circle. So where is the x value 1/2? That's up here at pi over 3. And down here at 5 pi over 3. Pi over 3, 5 pi over 3. Those are my answers for this first equation. Pi over 3, 5 pi over 3. And for the second equation, secant theta minus 1, we have secant theta minus 1 equals 0. Secant of theta equals 1. Soulmates. Very important. Listen, it makes math fun for me. So there. Reciprocal of 1 is simply 1. This is an x value. We're asking where on the unit circle is the x value 1? And that happens one time in that first revolution here at 0. So we have theta equal to 0. And those are all of our answers. So we have theta equals 0, pi over 3, and 5 pi over 3. Just combining those answers from those two. All right, so there's that one. Let's do another one. Cosine of 2x minus cosine x is equal to -1. All right, so let me just copy this down. Cosine of 2x minus cosine x equals -1. I'm going to take you and drag you. All right. This is the equation we're working with. Cosine of 2x minus cosine x equals -1. Here are the identities we have to work with. This is very obviously a double angle situation. We have a double angle. Very clearly, we need to choose one of these three. So here's the gist of it. You could choose any of these three, and eventually you will get to the right spot, but you might need to go through a process. There is a smart choice to make here, and let me talk you through what the smart choice is and how my brain kind of walks through the process as the superpower I've developed over many years of math. So I'm looking at this, and I know it would be really nice to have a cosine squared. So if I'm kind of deciding between all of these, I would say, like, I don't want to deal with this one because I have a singular power of cosine, so I want to have cosines involved. And then I'm looking at this and I say, well, this one would have a sine. Again, I don't want to have sines and cosines. That would be obnoxious. That's not what I need. So I'm limiting it down, this guy here. I need to use cosine of 2x is equal to 2 cosine squared x minus 1 because that's the only way that I will only introduce cosine squares and nothing else. So coming down here, we are going to replace, let me highlight that in green. We are going to replace cosine of 2x with 2 cosine squared x minus 1. That is the double angle formula. Then minus cosine x equals -1. I am going to rewrite this, 2 cosine squared x minus cosine x. If I add 1 to both sides, the 1s will cancel. So this whole thing is equal to 0. This is not, it's an undercover quadratic, but in a different type of way. We don't really even need to think about this as a quadratic because there's no constant term. The easiest thing for us to do here would be to factor out the cosine x. So cosine x gets factored out. You're left with 2 cosine x minus 1 as the additional factor there. And we can set each of these equal to 0, right? We're just playing the game we've played millions of times. So we have cosine x is equal to 0. We're talking about x values here. Oops. X values. So where on the unit circle is the x value 0. And that happens at pi over 2 and at 3 pi over 2. And then for this second equation, 2 cosine x minus 1 equals to 0. Cosine x is equal to 1/2. I then am looking for x values. So where on the unit circle are the x values 1/2? I know positive x values happen on the right-hand of the circle, right-hand side of the circle. I have pi over 3 and 5 pi over 3. Pi over 3, 5 pi over 3. So x is equal to pi over 3, 5 pi over 3. All right, so all together, those are my answers. Again, I always put them in, I like to put them in order, but you don't have to. Um, the answers would be pi over 3, pi over 2, 3 pi over 2, and 5 pi over 3. Bam, bam, thank you, ma'am. All right. So these ones, just kind of think your way through, make substitutions, try things out. Worst case scenario on this last one we had done, if we had chosen the wrong thing, just like kind of quickly would like to talk about what would have happened if we had chosen the wrong thing. Why don't I insert a page right up here? Right. And you can turn off this video at any time, obviously. I'm not holding you captive here. You have free will and can choose to stop watching this video at any point in time. But if you're curious, if you are a curious math student, what would have happened, Professor Cook, had I made the wrong choice there instead of the right choice? Well, let's say you made the choice to do this cosine squared x minus sine squared x. If you had done that, you would have cosine squared x minus sine squared x minus cosine x is equal to -1. And you would have said, okay, well now sine squared is a problem for me because I don't want any sine squareds in there. So you would have come back to the drawing board. You would have said, all right, well then what can I use to get rid of sine squared? Aha, it's orange here. Aha, I can use this guy right here. So you would have cosine squared x minus, you would be careful with your parentheses, of course, 1 minus cosine squared x end parentheses, minus cosine x is equal to -1. So what we had done there was replace sine squared with 1 minus cosine squared x. You would simplify cosine squared x minus 1 plus cosine squared x minus cosine x equals -1. You now have two copies of cosine squared x. So that's 2 cosine squared x. Minus cosine x, add 1 to both sides, it cancels out, equals 0, back to where you started. That's what would happen. The same thing would happen if you had made the substitution 1 minus 2 sine squared. You would have done 1 minus, so you would have started right up here. Sorry, just pause there for a second, lost my train of thought. All right, back to where we were. Cosine 2x minus cosine x equals -1. If we had done the other one, duplicate this guy over here, and done 1 minus 2 sine squared x instead of cosine of 2x, we'd have 1 minus 2 sine squared x minus cosine x equals -1. You would have thought the same thing here. Hey, I need to do something about the sine squared. What can I do about the sine squared? Well, we have, again, the same exact formula, 1 minus 2 cosine. 1 minus cosine squared is equal to sine squared. So 1 minus 2, 1 minus cosine squared x. It all would lead back to the exact same place that we were. Distribute the 2, 1 minus 2 plus 2 cosine squared x minus cosine x equals -1. Here you have 1 minus 2, which is -1. Add the 1 over, it cancels. 2 cosine squared x minus cosine x. So don't be afraid to just try things on these. Even if you had made the less good choice, you still could have got there no matter what. Just try things out always, and I will see you in another video.